Saseni, karibuni sana kwa video yetu ya leo. Leo tutaendelea kusoma juu ya operators in C program. Tutaangazia types of bitwise operators. Last video tulisoma juu ya introduction to bitwise operators in C program. Katika nursery school, natumai kila mtu hapa ameenda through nursery school, ulisoma hesabu, na hesabu ya kwanza ulisoma juu ya numbers. Ukasoma nambari 0, 1, 2, 3, 4, 5, 6, 7, 8 na 9. Yani you went through numbers. You are taught about numbers from 0 to 9. Those numbers are called decimal numbers, and they are used in mathematics. Now, sasa hizo decimal numbers, they are created in the base 10 numbering system. Kwa hivyo kuna numbering system inaitwa base 10 yenye inazitengeneza nini hizo numbers ulizisoma nursery school. Sasa hizo numbers ukizihesabu zote zinakuanga kutoka 0 mpaka 9 na zote ni 10, ndio maana zinaitwa base 10. Yani ukiziandika unaziandika in the power of 10, meaning that ni 10 multiplied by itself a certain number of times. 10 into the power of 0 is 1, 10 to the power of 1 is 10, 10 to the power of 2, meaning that is 10 times 2, yani 10 times itself multiplied by itself a certain number. Kama hapa imeandikwa 10 into power of 2, kwa hivyo una multiply times 2 ni 100. Then 10 into the power of 3 is 1000. 10 into the power of 4, meaning is 10 times 10 times 10 times 10 is 10,000. That is decimal numbering system. That is the normal numbering system that we use in mathematics, that we were taught from nursery school until where you are. Sasa katika computer kuna pia numbering system inaitwa binary numbering system. We say binary has 2 digits. Tukasema ni 0 na 1. Hizo digits mbili they form base 2 kwa sababu ni mbili, base 2 numbering system. Yani ukiandika unaandika in the power of 2, yani 2 multiplied by itself a certain number of time. Kwa hivyo unarudia 2 times 2, 2 times 2 times 2 depending on which power you want to create. Most of the modern computers, they use this numbering system. Kwa hivyo ukinunua computer ujue numbering system yake inaitwa binary number system. Ni mfumo wa kuhesabu katika hizi computer za kisasa. Base 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3. When you say 2 to the power of 3, we mean 2 times 2 times 2. Yani 2 3 times. Ndio 8. 2 to the power of 4 is 16. These numbers are very, very important. These 1, 2, 4, 8, 16, 32, 64, 128. These numbers are very important. It is very important for you to memorize them. Uziimbe kama venye unaimbaka 1, 2, 3, 4, 5, 6, 7 hivyo. Uimbe 1, 2, 4, 8, 16, 32, 64, 128. So uziimbe kuziimba kama wimbo. It is very important to know them so that you can understand how binary numbering system works. So next we are talking about how to convert the decimal numbering, yani ile namba ya kawaida kuiconvert into a binary number. Namba ya kawaida ni kama 14. 14 ikiandikwa katika binary number inaandikwa 04 13 na 01, yani 0000 111 and then 0 at the end. There are rules for converting the decimal point into the binary number system. The first rule is you start from right, then you move to left. Yani unaanza kulia ukienda kushoto. Then the next one is you divide the number by half and ignore the remainder. Yani unagawanya ile namba umepewa, unaigawanya na mara mbili, alafu unapuuza ile remainder inabakia. Unaipuuza, uiangalie. Alafu rule ya tatu ni unaandika moja kwa old number. Tukisema old numbers, tunasema numbers zenye ziko na remainder kama 3, tuko na 5, tuko na 7, tuko na 9. Yani those numbers are not divisible by 2. Yani ukidivide by 2 lazima upate nini? Remainder. Even numbers are numbers without remainder, yani they are divisible by 2. Kama 2 itself, then 4, 6, 8, those ones are even numbers. So ukimaliza kuziandika zile namba, unaangalia zile ziko na remainder, unaweka 1. Zenye hazina remainder unaweka nini? 0. Tuko na example hapa, we are given a number 240. So 240, the first rule is to start from right to left. Kwa hivyo right tutaanza hapa 240 tukielekea hivi left mpaka tuende mpaka kwa 1. So 240, the next rule is to divide by 2. So 240 divide by 2 unapata 120. 120 divide by 2 unapata 60. 60 divide by 2 unapata 30. 30 divide by 2 unapata 15. 15 divide by 2 unapata 7. 7 divide by 2 unapata 3. 3 divide by 2 unapata 1. Kwa hivyo ukimaliza kudivide by 2 unaangalia namba ambayo iko na remainder unaweka 1. Yenye ina remainder unaweka 0. 1 hapa ni old number, unaweka 1. 3 iko na remainder 1. 7 iko na remainder 1. Then 15 iko na remainder 1. 30 haina remainder 0. 60 haina remainder unaweka 0. 120 haina remainder unaweka 0. 240 haina remainder unaweka 0. Kwa hivyo the binary number ya 240 ni 4 ones na 4 zeros. Sawa sawa. So ni 1111 then 0000. That one is the number of binary. Halafu tukienda katika ile table ya binary converter, tulisema hizi namba lazima umemorize, uziimbe kama 1 2 3 4 kama zile za nursery venye ulikuwa unaimba. Tutaziweka hapa, tuanze na 1 2 4 8 then 16 then 32 then 64 then 128. Alafu tuchukue hii namba yetu hapa yenye tumepata binary number, tuziweke hapa chini zote. Tutaanza na ones 4 alafu zeros 4 tuziweke vile tu zimeandikwa hapa juu. Alafu tuandike ile namba ilikuwa kuko na ones zote tuunganishe pamoja, to add, we add all the ones. Tuta add 1 ya kwanza, that is 128 plus 64 plus 32 plus 16. We have only 4 ones. These are the numbers. When you add this number, you will get a total of 240. That is the number that we were given. So meaning that this binary number is correct. Now, our topic was bitwise operators. In bitwise operators, we have 6 types. So today we are going to study the 4 types, then hizo zingine mbili tutazisoma baadaye. So we will study bitwise and bitwise or bitwise exclusive or bitwise not, logical left shift and logical right shift. So the logical right and left shift tutazisoma baadaye. So we are going to concentrate with the first 4. So tutaanza ya kwanza, that is bitwise and operator. Ukiona simbo yake inakuanga ni ampersand sign. So we have only one ampersand sign. Bitwise we have 1. In logical we have 2. So in bitwise and, it states that it will give 1 only if both operates are 1, otherwise it will give 0. So operate zote mbili lazima zikuwe 1 ndio answer ikuwe 1, otherwise itakuwa nini? 0. So tuko na operate ya kwanza ambayo ni A na ya pili ambayo ni B. Kwa hivyo A na B lazima zikuwe 1 ndio answer yetu hapa ikuwe 1. So hapa ya kwanza ni 0 na ya pili ni 0, answer ni 0. Hapa ya kwanza ni 0, ya pili ni 1, answer ni 0. Ya tatu ni 1, then 0, then we get 0. Then the last one we have 1 and 1. So 1 and 1, the answer is 1. So the answer will only be 1 if both the operate are 1. Kindly note that. Lazima zote mbili, operate zote mbili zikuwe moja ndio answer yetu ikuwe moja. Tuko na example hapa. Tumepatiwa variables mbili, 5 na 9. Sasa 5, ukiandika binary ya 5 utaandika 0101. Tutaangalia hapa sasa. Tumesema katika rule tuna divide by 2 hivi. Kwa hivyo 5 divide by 2 unapata 2, 2 divide by 2 unapata 1. Sasa katika hizi hapa tunaangalia all na even number. 1 iko na remainder kwa hivyo tunaweka 1. Then hapa 2 haina remainder kwa hivyo tunaweka 0, na hapa hivi E5 iko na remainder tunaweka 1. Kwa hivyo kuna 101. Then ya pili ni 9. 9 binary yake ni 1001. Sasa ndio tupate hii binary ya 9, tumekuja hapa tukasema 9 divide by 2 tukasema ni 4, 4 divide by 2 tukasema ni 2, 2 divide by 2 tukasema ni 1. Ukumbuke atuangalie remainder, tunafanya kuignore. So tumesema all numbers tunaweka 1. Kama 9 ni all numbers 1, 4 ni even tunaweka 0, 2 ni even 0, then 1 ni odd. Kwa hivyo tunaweka 1. So we have 1001. This is the binary number. Now hapa tumepatiwa logical AND. So with logical AND, for the answer to be 1, both the operators have to be 1. The operators have to be 1. So we have 5 and 9. So these are binary numbers. Both of them has to be 1 for the answer to be 1. So 1 and 1, the answer is 1. 0 and 0, the answer is 0. 1 and 0, the answer is 0. 0 and 1, the answer is 0. So our answer is 0001. That is the binary number. Now when you come to the binary converter, we put all the numbers that we say that we are going to memorize. 1, 2, 4, 8, like that. We put 1, then we put 0, 0, 0. If we put 1 and there is nothing else, the others becomes 0. So hapa tuko na 1, so our answer is 1. The next one is bitwise OR operator. It is represented by vertical sign. So hapa kuna vertical sign. Kwa bitwise vertical sign ni moja. Kwa logical tulisema vertical sign ni mbili. Usiconfuse. When you talk about bitwise, we are talking about only one vertical sign. So the answer becomes 1 if the operand is 1, otherwise it is 0. So anywhere ikiwa kuna operand katika hizo operand mbili, moja ni 1, answer itakuwa 1, otherwise itakuwa 0. So it will be 0 if both the operand are 0. Kwa hivyo A and B, operand kuna operand ya kwanza A na ya pili B. 0 and 0 becomes 0, 0, 1 becomes 1, 1 and 0 becomes 1, then 1 and 1 becomes 1. So it will only be 0 if both the operand are 0. Ndio answer ni 0. So we have the same variables 5 and 9. We said this one is how we count the variables. Binary numbers are the same. For 5 we said it is 0, 1, 0, 1. For 9 we say it is 1, 0, 0, 1. So we have said that both the operand should be 0 for the answer to be 0. Otherwise the answer will be 1. So 1 and 1, the answer is 1. 0 and 0, the answer is 0. 1 and 0, the answer is 1. 0 and 1, the answer is 1. So when we put this binary inside the converter, this one is the converter whereby we have 1, 2, 4, 8, 16 like that. We put 1, 0, 1, 0. So when you put like this, we are going, then when you put until here, this one is the last number. The others we just put automatically zeros. Hizo zingine unaweka nini? Automatically zeros. So kwenye kukona 1, tuna add. Kwa hivyo tuna add 8 plus 4 plus 1. Kwa sababu hapa hii ni 0. Kwa hivyo tunaanza 8 plus 4, hapa kuna 1 na hapa kwa 1 kuna 1 pia. Tunaziunganisha. Tukiziunganisha tunapata 13. So 13 is the answer for this binary. Sawa sawa. 13 is the decimal number. We are given the same variables 5 and 9, and here we are looking at exclusive OR. So in exclusive OR, we say that the corresponding variable should be 1 for the answer to be 1. This one is 1 and 1, the answer is 0. 0 and 0, the answer is 0. Then 1 and 0, the answer is 1. Then 0 and 1, the answer is 1. So when we put it in the binary converter, we find that we have 0, 0, 1, 1. So we are adding the 1s. So we are adding 8 plus 4. 8 plus 4 is 12. So the answer there is 12. 12 is the decimal number. The next one is complement operator. Complement operator is shown by a symbol of tilde. So you exchange 1 to 0 and 0 to 1. Kwa hivyo una exchange. Ikuwa moja ni 1, unaichange inakuwa 0. Ikuwa ni 0, unachange inakuwa 1. So hapa tuko na 0, imechange inakuwa 1, 1, then inachange inakuwa 0. Hiyo ndio complement operator. With complement operator, we are using one operator. So we are using 5. We said 5, this one is the binary number. So where there is 1, we change to 0. Where there is 0, we change to 1. Where there is 1, we change to 0. 0 to 1. So we are changing this binary into this. Then when we put the binary inside the converter, we have 0, 1, 0, 1 mpaka hapa. Hizi zingine zinafaa kuwa 0. Kwa hivyo tutaziconvert pia hizo zikuwe nini? 1, because we are converting everything. So when you convert everything to 1, the total will be 250. So we will go to code block, we write this program, we get to understand more about bitwise operators. So we will start by declaring variable. So we say unsigned character A is equals to 5. We will use the example we are using. Then B is equals to 9, semicolon. We are using unsigned because we want to work with whole numbers. So we will go to printf, we change this one. So we say A is equals to and D, semicolon, B is equals to and A, D. So there we want to give the value of A and B. Then we copy this one, we paste here below. So printf A, and we put A and B, because we want to find and B. A and B is equals to and, then comma, then here we put \n. Then we delete this one because we just want the value of A, the N, and B. So we copy, then at the end we put semicolon, then we copy this one, copy, then we paste here below. We just change this one to or, then we change this one to, then we change this one to, we said this we use only one operator, so we have this. So A, then this one should be A. We are looking for the value of A. Yes, so this one P, this one will also change the sign. Then this one we change the sign. Then here, this one we have deleted the closing bracket, then semicolon. I hope we don't have any errors. Semicolon, semicolon, semicolon. We have a semicolon here. This one we have a semicolon. We will say A is equals to, so that we can get the value of A. Yes, so I don't think there is any errors. In case of any errors, we will correct. So we first save and we build our program to check the errors. So we are still building. We have 0 errors and 0 warnings. So we run the program. So we have gotten the first one. The first one we are saying we print the value of A and B. So we have said A is 5 and B is 9. So the next one we have A, we have bitwise A and sign B. We have 1, then A bitwise OR we have 13, then A bitwise exclusive OR we have 12, then we have this one is 250. Make sure you write the code correctly so that you can get the best answer. So we have written this code and the answer we have gotten is 1, 13, 12 and 250. Make sure you write the code correctly so that you can get the best answer or the best results. Asanteni sana, mkumbuke kulike hii video na msubscribe kwa hii channel.